Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be looking at 10.4, which is looking at mutually exclusive or non-mutually exclusive events. We talked about this a little bit briefly in 10.1 when we're looking at probability of an event occurring. We are going to be looking at what is a union, either A or B occurring, which we notated as the union symbol, which looks like a U, A or B. Now, the probability formula for this is going to be a little different depending on whether the events are either overlapping or what we call mutually exclusive. In mutually exclusive events, there is no overlap. So if I'm looking at an outcome of an event, it can either be A or it could be, there's no way it could be both. Whereas an overlapping event or a non-mutually exclusive event, there is a possibility that both are occurring. So the example here would be, let's say we look at, let's say we're looking at a standard gaming die. So a standard gaming die would be numbered 1 through 6. And so let's say A, we'll call A the event of rolling an even number, and we'll say B is a probability of rolling a 2, for instance. So the question is, well, could I roll a number that is both even and a 2? If so, then this is an example of an overlapping event. If not, then this is an example of a mutually exclusive event. So, of course, 2 is an even number, so when we're looking at the probability of A or B, and there is an overlap, we can't simply just add the individual probabilities, right? Probability of A, rolling an even number, would be 3 out of 6, or 1/2. The probability of rolling a 2 on that die is 1/6, because there's 1, 2 out of the 6 combinations. Where the problem comes with overlapping events is that you are counting the number 2 here twice. The even numbers on a die are 2, 4, and 6, and of course 2 is itself. So you're counting the 2 twice. So in terms of the formula, you are adding the individual probabilities, but then you have to subtract the probability that this event is both events are occurring, which would be A and B. So the probability that you roll an even number and it's a 2, well, that's the 2, which is 1 out of 6. And once you do the arithmetic, you get 3, 6, or 1/2. Okay. Now, you can also get this from completing a sample space. So if you looked at the outcomes of a die, 1 through 6, you could go through and say, okay, well, how many of these are even? 1, 2, and 3. And then my B event, that's the 2. So how many are highlighted? 3 out of 6, which represents 1/2. Okay. Now, if the events are mutually exclusive, meaning you can't have both occur at the same time, then the probability of A or B occurring is simply just adding the individual probabilities. So probability of A plus the probability of B. So for instance, let's stick with the die example here. Let's say A was the probability of rolling a number greater than 6, or greater than 4, let's say. And let's say B was a probability of rolling a number that was less than 4. So there's no way that I could roll a number that is both greater than 4 and less than 4. Therefore, this is an example of events that are mutually exclusive. There's no overlap. So to find the probability here, you would take the probability of each event and add them together. The probability of rolling a number greater than 4 would be 5 or 6, so 2 out of 6, plus the probability of rolling less than a 4 would be 1, 2, or 3, so 3 out of 6. So the probability of A or B occurring would be the sum, which is 5 out of 6. Now, most commonly in these types of examples, you're going to be looking at either rolling a die or rolling a pair of dice or drawing a card out of a deck. Those are the most common. Remember that if you roll 2 dice, there are 36 total combinations. If you're looking at a standard deck of cards, there are 52 cards with 4 suits and 13 different face values. But that's it for today. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.